Okay, this video is about Atwood machines, and before we begin, what I'd like you to do is take a look to the right, and there are two masses that are attached by a pulley, by a string. What I'd like for you to do is to draw a free body diagram of both masses. Okay, I would pause the video and give it a shot. Well, let's see. First of all, I have the first one to the left. We're going to call that the mass 1, and we're going to call the weight 1 going down and the tension going up. And then the second one over to the right, we'll call that one mass 2, with the weight going down and the tension up. Now, one of the common problems that I see is that students have a tendency to put in the mass in their free body diagrams. That is not correct. Remember, mass is not a weight, because weight and mass are different things. Masses are not forces, so we're going to take them out of our free body diagrams. Okay, today what we're going to do is we're going to solve problems using Atwood machines. Okay, and when you solve any Newton's laws problems, anything dealing with dynamics, you're going to use the same technique for every single problem. Okay, the first thing you want to do is you want to create a free body diagram. Then you're going to choose your direction. Now remember, in choosing your direction, you can make left being positive or left being negative, or up being positive or up being negative, or you can even tilt your coordinate system and choose the direction there as well. It's all legal. As long as you stick with it the entire problem, you're fine. The next question is the most important, I would say, of all of these, and that is to determine, is the object in equilibrium or not? Okay? In other words, is the object at rest, or is it traveling or moving at a constant velocity? If the answer is yes, you're going to take all of your forces and sum them equaling to 0. If the answer is no, then you're going to apply Newton's second law and sum all the forces equal to mass times acceleration. All right, and the last thing you want to do is create a system of equations and solve. Basically, you're just taking your algebra skills to use and solving that system of equation for whatever variable that you need. So let's take a look at an example. All right, well, we've got these two masses, and they're hung by a string, and the string wraps around a pulley as shown to the right. Determine the acceleration of the masses in terms of g, m1, and m2. Now notice there are no numbers in here. Okay, so be prepared on the AP exam to always solve for the variables, and those variables will tell you something about the problem. Okay, very rarely are you going to use numbers and plug and chug. But at the end of this lecture, though, I do have a practice problem where you do put in numbers. But again, I want to strongly encourage you to always solve for the variable first and then go from there. Okay? All right, well, our free body diagram, we already did that, so I'm not going to go over it. So let's go on to step 2 here. Now, step 2, you're going to choose your direction and follow along with me here. It's a little tricky at first, but it gets better as you practice it. Notice here on mass 2, if I go straight up, my acceleration is going up. So as this mass, because it's less than that one, as this one goes up, the string's going to go around, this second one's going to go down. And so what I have here is I have one direction here and one direction going down there. But if I take and just move this string from a vertical to a horizontal, then we can see something a little different here. Okay? The acceleration is going away from the small one and towards the large one. Acceleration away from the small one towards the large one. So what I'm going to do is I'm going to change my coordinate system to my horizontal, and from there I'm going to draw my free body diagrams. So my weight is now going to be going to the left for the first one instead of down, and the tension to the right. For the second mass, my weight is going to go to the right with my tension to the left. Now I would take a couple of minutes to visualize this and see exactly how this works. In every problem, it's going to be useful for us to do it this way. Okay, so let's move on. I'm going to define anything going to the left as being positive and anything going to the right as being negative. And I'm going to stick with that. Okay, well, is this in equilibrium? Well, we have a larger mass and a smaller mass. I'm going to say the answer is no. So therefore, we're going to use the sum of all forces equaling mass times acceleration. Okay, so step 4, I set up a system of equation. Now, I'm confident that at this point, you should be able to set up a system of equations already, but I'm going to walk you through it real quick here. Okay, so for the mass 1, the first one, I've got it's accelerating. So the sum of all forces is equal to the first mass times its acceleration. I'm going to treat this as my system. And that's going to be equal to, all right, the weight's going to go in the positive direction here, and my tension is going to go in the negative direction here. Now for my second system here, I've got my mass 2, and it's also accelerating. So the sum of all forces is equal to the mass of the second one times acceleration. And that is equal to, now we've got the tension going in the positive direction and the weight of the second one going in the negative direction. So here are my two systems that I've just created from free body diagrams. I've treated them as individual systems here. All right, so now the last step is to let's just plug and chug here. Let's get all of our variables in order here. I'm going to start here with, I've got the similar mass 1 on both sides of this equation here, and I've got the tension. So what I'm going to do is I'm going to move these over. I'm going to move the tension on one side and move this mass over to the other, and so I've cleaned that up. Next, I'm going to take this tension and notice that it's the same tension for my second equation over here. So I'm going to go ahead and insert all of this stuff in here for my tension. So I'm going to do that here. Now the next thing, I can take a look. I see, well, I've got an acceleration here and an acceleration here. So I'm going to move all my like terms to one side and all my other terms to the other. And there you go. And because I have the same term for both, or the same variable for both of these terms, I'm going to pull out these two from my acceleration here. And then I'm going to go focus on the other side. I've got my two g's here. They're the same on both sides, or this side here. So I'm going to pull this g out of both of these terms, and I've got this. Okay. And so finally, let's move this back up. I'm going to go ahead and notice here that I want to get rid of acceleration, or this term here, and isolate acceleration. So I've got this term here in parentheses. I'm going to divide it to both sides. It cancels on this side, and I end up with the answer here. So now what I've done is I've calculated the acceleration in terms of g, mass 1, and mass 2. Okay, so here's an example where you can use the same technique, and I would highly suggest that you solve for the variable and see if you can come up with the answer. Okay, so I'd pause the video and work on it, and then I'll reveal the answer in a second. But again, I want to strongly encourage you to solve for the variables first, then put in the numbers. Give it a shot. All right, well, hopefully you got 3.3 meters per second squared as your acceleration. All right, remember, if you have any questions or need tutoring and you live in the Phoenix area, just go ahead and give me an email at monroe.watson@gmail.com. Thank you.